All right, let's go over the last example. Example number 3 of composition of these two functions, h of x equal to cube root of x minus 4 and f of x equal to x cubed plus 4. I already go ahead and found the domain of these two functions because for the function h, well, for any odd root function, it is okay to have any negative number underneath any odd root. So you can take any negative number, you plug it in here, you crank out a negative number. Well, the odd root, any odd roots of any negative number is still going to give you a valid result. So that's why there's no discontinuity in this odd root function, I should say. So that's why the domain of h of x is from negative infinity to positive infinity, all real numbers. And same thing for the f of x function. So we don't have any denominator. So that's why the domain is also all real numbers. Now, what about h composite f in terms of x, which is h of f of x? Well, h of f of x is, just like we did earlier, take the entire function f and replace the x of the h with that f function. So this is going to give us cube root of x cubed plus 4 and then minus 4. Well, this is going to be just cube root of taking away the parentheses. 4 and minus 4 cancel out, we're left with just cube roots of x cubed. But cube root of x cubed make the power and the root cancel each other out, so we're left with just x. And of course, the domain of x the domain of this function is going to be, now with the composition of h of f of x being x right here, what is the domain of this? The domain of this composition of function is also going to be all real number. Why is it all real numbers? Because when we take a look at the inside function g of x, which is x cubed plus 4, the domain of the inside function is all real numbers. So it has no restriction, meaning that it doesn't have any x value that says, x cannot be equal to this and that. Well, because the domain of the inside function is all real numbers, and because the domain of the result is also all real number with no restriction anywhere, or particularly no restriction from the inside function, the domain of this composition of function is also all real numbers. Now, what about f composite h in terms of x, which is f of h of x? Well, let's say h of x is this whole thing. Well, we take this whole thing and replace the x of the f with the one in red. So that's why we are going to have cube root of x minus 4 raised to the third power and then plus 4. Well, cube root raised to the third power means the root and the power cancel out, so we're left with just x minus 4 plus 4. Minus 4 and plus 4 cancel out, we're left with just x. Well, what is the domain of this? Well, same thing. Looking at the inside function h, the domain of the inside function is all real numbers. So that means it doesn't have any restriction as well. And the domain of the result, x, is also all real numbers. So because there's no restriction anywhere, either from the result or from the inside function, the domain of this composition is also all real numbers. So yeah, that's how we find the domain. Now, if x equals to -2, then what? Then h of f of -2. Well, h of f of x equals to x. So if x equals to -2, then h of f of -2 is going to be equal to -2. And if x equal to -3, then f of h of -3 is going to be equal to -3 as well, because f of h of x is equal to x. And if x equals to -3, we replace all of the x which is just this one with -3, and that's how we got that. And yeah, that is how we do this problem. So again, you know, the most difficult step is finding the domain of the composition of function. And as mentioned in the previous 2 videos, when you find the domain of the composition of function, you particularly want to find the domain of the inside function once you plug it in, and try to see if the inside function's domain is going to have any restriction, meaning that is it going to have any like x cannot be equals to this number or that number, and if it does, you want to include it in the result. But if it doesn't, and if the domain of the result also doesn't have any restriction, then yeah, that's when you get to say the domain of the composition of function is all real numbers. But if either the domain of the inside function or the domain of the result have anything like x cannot be equal to a number, then you want to exclude that x value out. So that's why you can say that all real numbers except x cannot be equal to da da da.